So we said that in this way we found the tension force in the spring. Okay? Now, what is the next step? It's true that we have found the tension force, but it's not enough, because you know that for a force, you should, to define it completely, you should know the magnitude and you should know the direction. Okay? So in order to be able to project your force into x, y, you need to know the direction of the force. So you need to compute what is the angle here between the tension force and the bar, the rod. Okay? To find the angle between the tension force and the rod, also we can use geometrical properties. So if you go back to your triangle here, you can say that the angle between the rod and the spring force is equal to this angle. And from geometry, you can use sine law to find angle phi. Okay? Because in this triangle, you know, and this angle, which is 150, and you know the length of all your sides of triangle. So by applying sine law, you can say that sine phi over the opposing edge, which is C, is equal to sine of 150, which is this angle, over L. Okay, so from here you can calculate what is the value of phi. Once you find phi, so you know everything about your force, you know its direction, you know its magnitude. So now you can project it on x and y. And now we can move to the next step in this problem, which is writing the three equations of equilibrium. To start with, I will do some of moments about a point. So I can select A, because A is simple, because AX, AY pass by A, okay? And as you can see here, for your spring force, you can divide it into X component, which will pass by point A and will not produce a moment, and Y component, okay? So now, if we do sum of moments about A equals to 0, what do we have? If we choose the counterclockwise as positive, so choosing the counterclockwise direction as positive, we have that the moment of NB is counterclockwise, so it's plus NB times this distance, which is A. Okay, so we have plus NB times small a. Now you have the moment of y component of the spring force, and as you can see, it's producing a clockwise moment, so it's minus the y component of the spring force. To find the y component of the spring force, you should multiply by what? Look at the figure. You have the angle phi is with x-axis. So when you want to find the component along y, you should multiply by sine phi. So it's minus k times L minus delta, which is magnitude, okay, times sine phi to obtain the y component, okay, and then I multiply by the distance which is a plus b, okay, so times a plus b. Okay, and now this is equal to 0. I am done with equation number 1. This is equation number 1. Okay, now I can move to my other equations. My other equations will be sum of x equals 0 and sum of y equals 0. So if I write sum of x equals to 0, what do I have along x? So I have ax plus, what is this second component along x? Is the component
Tension.
of the spring force. Yes, and as you can show, as you can see, it's negative. So it's minus k times L minus delta. Okay, and I should project it on x, so I multiply by cosine of phi equals to 0. This is my equation number 2. As you can see here, You know, the only unknown in this equation is AX, so I get AX, okay? And from equation 1, the only unknown was what? The only unknown was NB, because I know everything about the spring force. So from 1, I get NB, okay? From 2, I get AX. And finally, I write that sum of y equals to 0. So what do I have along y? I have AY plus NB and minus K times L minus delta times sine phi. So the only unknown in equation number 3 is AY. So I get. So here, if you want, it's a simple system because each equation will give me one unknown. Sometimes it will be more complex. What I should do, I write the 3 equations with the 3 unknowns, and I can solve with the calculator a system of 3 equations with 3 unknowns. However, here it's simple, so each equation will give me one unknown. Any question on this? Okay, so we will continue next time. Have a nice weekend.
Thank you,
Bye.
doctor.
Thank you, doctor.
Thank you, doctor.
Welcome.